Hello everyone, this is Gunjan again. Let us continue our revision sessions. So previously we have discussed the first and second chapter. So now let us start with some interesting topic of chemistry. So we'll be continuing our fourth chapter, metals and non-metals. So let us find out. So by now you might be very familiar with different types of materials. Like you might have seen aluminum, you might have seen copper, you might have got a piece of charcoal, you might have seen a chalk. So all these are types of materials. But are they same? No, they are not same. Some of them are called metals while the others are called non-metals. So how do we get a difference between metals and non-metals? Is there any point of comparison? Yes, there are lots of ways which you can compare between metals and non-metals. So given we have an example of certain instruments that we find common, these are some materials. So say for example iron, we know iron is a metal. Coal, well I don't really know what coal is. Sulfur, again I'm not sure. Aluminum, oh yes, I know aluminum is again metal. Copper, again copper is a metal. Why do we know these are metals? Because in your house you might be able to see certain utensils which are made up of either aluminum or copper. You might see a lock that we put on our door that will be made up of iron. So we know that these materials are metals. The materials which we do not know are non-metals. So let us see how we can distinguish between metals and non-metals. Now you can distinguish between metals and non-metals with two types. The first we call them physical properties. These are nothing but those properties that you can see, that you can feel with your hands, the feeling that you get when you see a piece of metal and a non-metal. The other are chemical properties. What are chemical properties? It happens within the matter. So you are not actually able to see unless you add certain chemicals to them. So if you add certain chemicals and you get a particular reaction, you know, oh, this might be metal. If you add certain chemicals and you get some other reaction, you know this might be non-metals. And we will be discussing these chemical properties in a while, but let us start with the physical properties. So for metals, the physical properties would be, if you look at a metal, it usually has a very shiny surface. Say for example copper, aluminum, iron. If you see, light reflects from these metals very hard as compared to non-metals. So they have a shiny surface, they have a luster. What next? You might have observed that if you ever had a chance to visit an ironsmith, you might have observed that he keeps on hitting a metal with a piece of hammer. So what he is really doing there? So you might have wondered that if you take a piece of nail and you hit it with a hammer very hard, the shape of the nail will get changed. But the same thing does happen with a piece of coal? No, right? If you try to hit a piece of coal with hammer, it will break into several pieces. Taking another example of a wood. Again, wood is very solid. It is again very hard. But I am able to bend a nail. I am able to bend an iron nail. What is nail? Nail looks something like this in this picture. So this is a nail. So if I want, I can put a pair of tongs and I can bend it. But can I bend the wood? No, right? If I try to bend the wood, it will get broken into two pieces. So I can say wood is not metal, but iron or aluminum or copper are metals. Why? Because they have a shiny lustrous surface. They can bend easily. Now what is this property called? Let us find out. So a property which allows the metals to get compressed into thin sheets. This property is called malleability. What is this property called? This property is called malleability. It is spelled like malleability. So how is this useful? Where have you seen such sheets? You actually have seen these sheets a lot many places. Say for example, there is an open overhead tank on your house. So if you are not able to find lid, what some people might have done is they used to put an aluminum sheet over it just to cover it. Another very common example would be, we all like the sweet called Kaju Katli, right? So what our sweet makers do is they create a layer of silver. They create a layer of silver over this sweet to make it more attractive, right? हम काजू कतली खाने जाते हैं तो उसके ऊपर जो परत होती है वो किसकी बनी होती है? That is made up of silver. वो चांदी की परत रहती है. Similarly, if you are going out on a picnic and you want to eat you want to eat the food out there, so what does your mother do? She will make some theplas, she will make some sabji, and then she will wrap it in aluminum foil. So what is this aluminum foil? So this foil is created by hardly beating the aluminum metal, and it is created so thin, and this property is called malleability. Okay, let's discuss one more property. Have you ever tried to touch a frying pan or any utensils that you have kept on your gas flame? Just try to touch it very quickly. You will feel it is very hot. But what happens if the same frying pan has a handle of plastic or wood? Does that handle get that much warm? No, right? It does not get that much warm. If you have a cooker and you have cooked some rice, so how do you lift your cooker? Do you lift with the body of cooker? No. Why? Because that will be very hot, extremely hot. You might get yourself burned. But if we lift it with the handle, which is made up of plastic or wood, we will not feel that much warmth on the cooker's body. So why does this thing happen? So we can say that metals are good conductor of heat, meaning heat can pass from one point to another point very quickly in metals, but this does not happen in wood. So we have another physical property of metals is that they are good conductors of heat. Let us try to find another property of metal. As shown in this picture, try to create a circuit having a cell. You can easily find a cell from your remote control. Put some wires attached with the anode and cathode of the cell. Connect one with a bulb as shown in this picture, and then put again a gap between here. So here, if you can see, we have a nail inserted between two wires. Right, we have a nail inserted between these two wires. So what do you think will happen? Will the bulb glow? Yes, it will glow. Why? Because the electricity is able to pass from one end of the nail to the another end of the nail easily. So we can say that a nail is a good conductor of electricity. Now what will happen instead of nail if you place a piece of wood? Shall the bulb glow? No, the bulb will not glow. Why? Because electricity cannot pass through water. What happens if you place a piece of coal there? Shall the electricity pass from the piece of coal? No, electricity won't pass because even coal is not a good conductor of electricity. But now instead of that, try to keep a copper piece. Shall the electricity pass through the copper piece? Yes, it will pass. Instead of copper piece, try to put an aluminum wire or an aluminum spoon. Will it pass? Yes, it will pass. So we can say that we already know metals were good conductors of heat, but now we also know that metals are good conductors of electricity as well. So we have, again, let us revise all the properties of metals. So metals do have lustrous, do have shiny surface. Another thing of metals is they are malleable, meaning they can be converted into thin sheets. Another property is metals are good conductors of heat. Another property is metals are good conductor of electricity. So these are the properties that we have covered so far. What next? During this experiment, have you ever imagined what was the wire made up of? The wire that we use to the wire that we have in our household tube lights, or your if the wire that is used to charge your mobile phone, all these wires are made up of metals, because metals are good conductor of electricity. But this leaves us to another property, that metals can be converted into thin wires. Can you convert wood into a wire piece? No, it will break. But that does not happen into metal. Metal can be stretched and it can be converted into thin wires. This property is called the ductility. So as you can see in your textbook, the property of metal by which it can be drawn into wires is called ductility. And now let us find another last physical property of metal. What happens if you drop a frying pan from your hands? You will get a very high sound. What happens if you leave any utensil made up of metal? You will again get a ringing sound. So we can say that metals have this property of making a ringing sound. Or the school bell, just to showcase that there is a change of period or there is a recess time, we use a metallic bell. We do not use a wooden bell, right? Why? Because even if you try to strike the wooden bell, it will not make high sound. But if you try it with a metal bell, it will create a lot of sound. So we can say that this property of metal is called sonorous. So the metals are sonorous in nature. So let's quickly see what are the physical properties of metals. So we know that they are hard, we know they are lustrous, we know that they can be converted into thin sheets, so we say they are malleable. We know they can be drawn into thin wires, so we can say that they are ductile. We know that it produces lot of sound, so we can say they are sonorous in nature. We also know that they are good conductors of heat and electricity. So these are some of the physical properties of metals. What about non-metals? Each of the property of metal are totally opposite as compared to non-metals. So meaning, if you see that metals are hard and lustrous, you can say that the non-metals are dull. You say that metals can be converted into thin sheets, non-metals cannot be converted into thin sheets. If you try to heat a piece of sulfur or carbon with a hammer, you will see the powder of charcoal or sulfur. It will not be get converted into thin sheets. So non-metals are not malleable. Can you convert them into thin wire? Try to convert a piece of wood into thin wire. Try to stretch it. It will break, but it will not get converted into thin wire. So we can say they are not ductile. Try to pass electricity from non-metals. So we'll soon realize they are bad conductors of electricity. Or we can say they are insulators of electricity. What happens if you try to heat a piece of wood? Will you be able to feel the warmth on the other hand? Like taking an example of frying pan. The handles of frying pan are made up of wood or plastic. Do they get heated as well as? No, they do not get heated. Only the frying pan, the metal portion of the frying pan gets heated. But the wooden handle or the plastic handle is still cooler. So we can say that non-metals are again insulators of heat. Do the non-metals produce any sound when they are dropped? No, they do not produce any sound. So they are not sonorous. So these are the physical properties of metals and non-metals. Now let us discuss the chemical properties of metals and non-metals. So having checked with the physical properties of metals and non-metals, now let us check what are the chemical properties of metals and non-metals. How we will check this? Well, we will make certain chemical reactions with oxygen, with water, with acids and with bases. We'll add non-metals to all these four, we'll add metals to all these four, and we'll find the difference. So let us check each of them in detail. So firstly, we'll consider the reaction of metals with oxygen. Let's see what does happen. So as seen in this image, we have kept iron and we have added oxygen to it. We also tried to burn magnesium and see what happens. So what happens is, when you add or when you react oxygen with any of the metals, it forms metal oxide. So if you add oxygen to iron, it will form iron oxide. If you try to burn magnesium, it will form magnesium oxide. Now we also want to check the nature of these oxides. Are these oxides basic in nature or they are acidic in nature? How can we check this? It is very easy. We can check this with the help of blue litmus paper or red litmus paper. If the red litmus paper turns blue, we can say that this is a basic solution. On the other hand, if the blue litmus paper turns red, we can say that this is an acidic solution. So let us see what happens if we try to place a blue litmus paper and we try to place a red litmus paper. So what you will observe is, if you try to place a red litmus paper on the metal oxide like here, if you see, they have put a red litmus paper on the rust of iron. What is the rust of iron? Rust of iron is nothing but when the iron reacts with the oxygen in air, and you might have observed that certain elements which are made up of iron gets this layer of reddish particles above iron. This is called the rust of iron. So if you place red litmus paper on the rust of iron, it will turn blue. The same happens with magnesium oxide. If you try to burn a strip of magnesium, you will get magnesium oxide, and if you place this powder into the red litmus paper, it will slowly turn into blue. So you can say that in general all the metallic oxides are basic in nature. So you can see that the oxide of magnesium as well as iron, they turn the red litmus paper into blue. So we can say that in general terms the metallic oxide are almost basic in nature. Now let us try the same thing with non-metals. So what happens if you try to burn non-metals? So non-metals are, some of the examples are phosphorus, sulfur. So if you try to burn sulfur, or if you try to add oxygen to sulfur, you will see that it forms sulfuric oxides. So this is a typical experiment for the burning of non-metal. In this case, they have taken the example of sulfur. So what they have done is, they have placed a lid over this tube, and within this tube they are burning the sulfur. So what happens is, some gas is released, because when you burn sulfur, it gets converted into sulfur dioxide, SO2. That is a gas. So you don't want the gas to get escape. So what you do is, you place a lid so that the gas doesn't run out of the test tube. Now add maybe a spoon of water to this test tube after the burning of sulfur. Then try to place the blue litmus paper within the solution, and you will observe that the blue litmus paper has turned red. So we can say that in general, all the non-metal oxides are acidic in nature. And this thing can be related in terms of a chemical equation, which I'm sure you will learn in your further standards, but it can be written in this way. So when sulfur reacts with oxygen, it forms a gas called sulfur dioxide, SO2. This is the formula of sulfur dioxide, SO2. Now when we added a teaspoon of water, it gets dissolved into water to form an acid called sulfurous acid, H2SO3. So it forms sulfurous acid when you add sulfur dioxide to water. And hence, since this is an acid, it turns the blue litmus paper into red. So we have checked what is the chemical reaction of non-metals and metals when we add oxygen to them. Now let us find out what happens when you try to add water to them. So say for example, you are adding water to sodium. Sodium is a highly reactive metal. So it reacts vigorously with water and releases hydrogen gas. But all the metals do not do the same thing. There are certain metals like iron, which does not react as vigorously as sodium does react with water. Because if you observe, if you have a piece of iron and you place it into water, it does not form rust as it is. Right? In terms of our native language, we can say that आप अगर किसी लोहे की चीज को बाहर रखते हो तो उसके ऊपर जंग तुरंत नहीं लग जाता. It takes a while to form these rust particles. So you can say that the reaction of some metals with water is slow as compared to other metals. And we will discuss this reactivity of certain metals in a while. What happens if we try to add water to non-metals? So let us take an example of phosphorus. Now again, phosphorus is a very highly reactive non-metal. If you just keep a piece of phosphorus outside in air, it will burn right away. It is very much reactive with the air. But if we place the non-metals into water, we get no reaction. So we can say that metals, if you add water, there is a reaction. Some might be very fast, some might be very slow, but yes, there is some reaction. But if you add non-metals with water, there is no reaction. So we have checked with oxygen and we have checked with water. Now let us check it with acids and bases. So let us find out like what happens when you try to add acid to a piece of metal. So firstly, this reaction is an exothermic reaction. And don't worry about this word right now, exothermic. You will learn this in your later standards. But what happens is when you add acid to a metal, it releases some energy in terms of heat. It also releases a gas called hydrogen gas. Now you might know that hydrogen gas is highly reactive. So when it is given some kind of heat, it burns right away. But there is a peculiar thing about the hydrogen gas burning. Whenever hydrogen gas gets burned, it creates a pop sound. Pop, pop. When the bubbles of the hydrogen gas are burnt, it creates a popping sound. So this is a peculiar thing about the burning of hydrogen gas. And this is observed when you place acid with metals. So I can say that the reaction of acid with metal is a highly exothermic processes. It releases some heat energy and it burns the hydrogen gas with a popping sound. What about non-metals reaction with acids? Well, again, there is no reaction when you try to add non-metals with acids. So now let us check what happens when we try to add bases with metals and when we try to add bases with non-metals. Now this is a bit complicated reaction. So when we try to add a base solution to non-metals, the reactions are very complex and it is beyond our position to understand at this point of time. But I'm sure you will learn this in maybe your 9th or 10th standard. Now what happens if you try to add base to metals? Well, there are certain metals which will react with bases and again produce a hydrogen gas and release, and it will burn the hydrogen gas. But there are some metals which do not react with the bases. For now, it is beyond our textbook to go beyond this to exactly know what happens when you try to add base with metals and non-metals. So we shall keep our discussion limited till here. Now there is another important chemical reaction which we will be discussing in this chapter. It is called a displacement reaction. Now displacement reactions are again a bit complicated, so we will not be covering into entire detail in this standard, but you will learn more about displacement reactions in your 10th standard. So let us see what is this activity about. So in this activity, as you can see, we have placed 5 beakers and we have labeled them A, B, C, D and E. In the first and second beaker, we have placed a solution for copper sulfate. So as you can see that there is a blue color for copper sulfate. It's A and B. Then in the next beaker, that is the third beaker, we have kept a solution for zinc sulfate. Now zinc sulfate is usually transparent, so you cannot see any color. In the D beaker, we have kept iron sulfate. Iron sulfate is usually a bit reddish or yellowish. So the D solution looks like a bit yellowish. And again in E beaker, we have kept zinc sulfate. Now what we have been doing, in the first beaker, that is A, where we have copper sulfate, we put a granule of zinc, that is a small piece of zinc. In the beaker B, where we again have a copper sulfate solution, we put an iron nail, that is iron. In the beaker C, where we have zinc sulfate, we put a copper turning. Again in beaker D, where we have iron sulfate, we again place copper turning, And in the last beaker, zinc sulfate, we place an iron nail. So let us observe what happens. So we'll soon observe that the first beaker which had started with blue color of copper sulfate gets converted into dark grayish. Why this happens is because the zinc which was added as a part of copper sulfate reaction reacts with the copper sulfate solution and replaces copper from it. And this can be seen here in the form of chemical reaction. So when we add copper sulfate and zinc together, zinc replaces copper. So we have new solution called zinc sulfate, and we have a copper which is getting deprived from copper sulfate. So we can say that the zinc displaced the copper in copper sulfate solution. We'll observe a similar thing in the second beaker where we added copper sulfate and iron. So what happens is iron displaces copper from copper sulfate. So we can say again this is a displacement reaction. Now let's see what happens in the third beaker where we had zinc sulfate and copper. Now we might think again the same thing should happen. The copper here should displace the zinc sulfate and the zinc part of the zinc sulfate. So we should get copper sulfate and zinc, but that does not happen. For beaker D, we think that iron sulfate and copper we added, so the copper will again replace iron in iron sulfate and form copper sulfate. But again, that does not happen. What about the beaker E? So in beaker E, we have zinc sulfate and iron. Does the iron replace the zinc? No, again, the iron does not replace the zinc. So what is going on? Why some metals are able to replace copper, but copper is not able to replace some metals? Well, this is because of the reactivity of certain metals. There are certain metals who are highly reactive. There are certain metals who are less reactive. And there are certain metals who do not react at all. And don't worry, you are not going to learn about this reactivity in this standard, but you will learn more about the reactivity in your 10th standard. So for now, what you can remember is in displacement reaction, a metal having less reactivity gets displaced by a metal having high reactivity. So zinc or iron are more reactive as compared to copper. Hence this metal replaces them in their solution and that metal becomes idle. So when we have copper sulfate solution and we add zinc, since zinc is more reactive as compared to copper, it will displace the copper part in the copper sulfate solution and copper will get alone. As seen here, when we add zinc to copper sulfate solution, we get copper which is deprived from the copper sulfate solution and we get zinc sulfate. This reaction is called displacement reaction. So that is all about the chapter. And let us see some keywords that we have covered in this chapter. So we know what is atom. Atom is the smallest particle of a matter is called atom. What is a conductor? Conductor, it depends on good or bad. So there are metals which are good conductors of electricity and heat, and there are non-metals which are poor conductors of heat and electricity. What is displacement reaction? The reaction where a lower reactivity metal or a metal having a lower reactivity is replaced by a metal having higher reactivity. So for example, we have a solution of copper sulfate, we add zinc. Zinc is more reactive as compared to copper, so it displaces copper from copper sulfate and copper gets alone. So this reaction is called displacement reaction. What is ductility? So ductility is the property of metals that it can be stretched into thin wires. What are elements? We have different elements in chemistry. So these are nothing but elements. Hardness is the amount of force that you have to apply before it breaks. So we can say metals are more harder as compared to non-metals. What is malleability? The malleability is the property of metals that it can be struck by a hammer or any other metal to get converted into thin sheets. Metals are part of elements. Then we have others are known as non-metals. And these metals have a lot of physical properties which keep them separated from non-metals. We have discussed throughout the chapter. The last keyword is sonorous. So sonorous is a property that it creates a ringing sound when a metal is dropped. So this property is called sonorous property. And we skipped a term called metalloids. So what are metalloids? So metalloids are some elements that have nature of metals as well as non-metals. We have a clear distinction between metals and non-metals, but there are certain compounds or elements which show the nature of both metals as well as non-metals. These are called metalloids. So that's it for the fourth chapter, metals and non-metals. See you later. Bye.